So in this chapter, it talks about the repeated measure ANOVA. So when it compares to the independent measures, the repeated measures design means the same participants take part in each condition of the independent variable. It means that each condition of the experiment includes the same group of participants. It is within groups. We can say that like each participant will be measured for 3 or more times, and for the independent measures design, each participant will only be measured uh, in one condition of the independent variable during the experiment. So the repeated measures can be applied when you want to measure the changes over 3 or more times points, or when you want to measure the difference under 3 or more different conditions. In terms of data and assumption, the data means that the same participant will be measured for the 4 or 3 or more times. It means that we will have different data for the same participant, and also the assumption of spracity. The assumption of spracity has to be examined. So my research question, I want to test the effect of positive intervention on regulation of anxiety. So I will measure the anxiety of 8 participants for 4 times. The first time will be before receiving the positive interventions, and the second time will be after receiving the intervention for 1 week, and the third time will be after receiving the intervention for 2 weeks, and the fourth time will be after receiving the intervention for 3 weeks. So the anxiety will be rated on a scale of 1 to 10, with 1 being highly anxiety and 1 being no anxiety. So in my research question, I want to say the effect of positive intervention, and to say when amount of time put on the positive intervention, how does it reduce the anxiety? So this is my data. So for each participant, it will be measured for 4 times. This is the anxiety level, and I have 8 participants in my data set. So for the test need to be conducted, first we want to conduct the assumption of spracity to see if it's made the assumption, and also we want to conduct the one-way ANOVA and also the post hoc test. So first I'm going to convert the time variable to be a factor, and it has the 4 levels like I have discussed. It will be before and week 1, week 2, and week 3. So next I'm going to create a factor to identify the participants, so it can be easily entered into the RStudio. So I'm going to explore the data and by using the by function. So from the data we can see the before receiving the positive intervention, the mean of the anxiety is 8 point, and after week 1 the mean is 7, and after week 2 the mean is 5.6. After week 3 it is 3 point. So it means that the positive intervention reduced the anxiety by exploring the data. So also we can use the ggplot to get the plot to have a better image of our data set. So from here we can get the picture of the data set. So before receiving the positive intervention, the mean of the anxiety is 8, and this is a 7 and 5.6 and 3. So in the next, I'm going to create the contrast that break down the main effect, and it can tell us the difference between the groups. And first, I definitely want to say the difference between before receiving the positive intervention and after the intervention. So through the contrast, we can say how the intervention works. And in this function, we create the before group as -3 and all the others as 1. So it can when it sum up, it will be 0. So for the second contrast group, we want to set the week 1 versus week 2, because I want to say if the amount of time put in the positive amount of time to put into the participant, will that be effective to reduce the anxiety, or will that just be the same? And for the third contrast, it is before group versus week 3. So it also this contrast also want to say when amount of time of the positive intervention used in each participant, will time be a factor that affect the anxiety level, or so the next function is to set the three variables to be the contrast for the time factor. So the next, I'm going to use this function to create a model and conduct a repeated measure design ANOVA to analyze the model. So right here we can have the result of the ANOVA. And one thing we want to address is the assumption of sphericity. So as we can see right here, the p-value is 0.4, and it is larger than 0.05. So which means the assumption has been made. So we can conclude that the variance of difference are not significant different. So the variance are basically equal in our in our data set. So if the assumption has been validated, we can use the Greenhouse-Geiser and the Hunt field corrections to correct the degrees of freedom of the F distribution. So when we're doing the correction, this value we need to pay attention. When this value close to 1, it means the more homogeneous of the variance of the difference. And there's a limitation of this value, is like in my dataset I have 4 conditions. That means the limitation would be 1/3, so it is 0.333 and continuous. So in the next we want to run the post hoc test to see the difference between the groups. As here we can see from here, it shows that the p-values were all significant less than 0.05, which means there is a significant difference between among those groups. So we can conclude that the anxiety was significantly reduced after receiving the positive interventions. So I'm going to run this function. This function is used to create a model, only include the intercept as a predictor, and for this function is to specify the outcome and the predictor variables. And right here I'm going to run the ANOVA to see the comparison between the two models. So as we can see, the p-value is significantly less than 0.05. So it means that the time is a significant predictor of anxiety. It means that with more time we put in, with more time we use the positive intervention to the participant, their anxiety level will be significantly reduced. So in the next, I'm going to run the summary function to explore the model to get more information.